Hello, Math 45 students. This is Cindy Enrique. We're going to continue Chapter 5 on page 22. So Section 5.4 is all about dividing polynomials. So dividing polynomials is very similar to long division. So we want to divide this polynomial by 3x minus 2. So that word by tells us that the polynomial afterwards is going to be what we divide by. That's our quotient. So we are going to have 3x minus 2. And on the inside, we're going to have what's in front of the word by. So that's going to be a 6x cubed plus 11x squared minus a 31x plus 15. And this was okay because we know that this polynomial, this four-term polynomial, is in descending order. Which means from biggest exponent to the smallest exponent. Okay, so what I'm going to do over to the side is I'm going to have my designated area for my scratch work. So this is where I'm allowed to be messy and it's not going to interfere with my answer. Okay, all right, so here we go. So it says, so the first term is the 6x cubed. So that's what I'm going to be focusing on is that 6x cubed. So I'm going to look at this first term as well. So 3 times what gives me 6? That's going to give me 2. X times what gives me x cubed? Well, that's an x squared. So I know that for that first term, I'm going to be looking at a 2x squared. So, okay, over on my scratch work, 2x squared, and it's being multiplied by my 3x minus 2. So when I distribute and multiply, I'm going to get a 6x cubed minus a 4x squared. And of course, because I'm doing a subtraction, I'm going to go ahead and deal with that now. So since the next step is subtraction, I'm going to multiply this entire thing by negative. So multiply by negative. So when I multiply this term by a -1, I really end up getting a negative 6x cubed plus 4x squared. So I'm going to write that down. Negative 6x cubed plus my 4x squared. So I know that 6x cubed minus 6x cubed cancels. That's going to be fantastic for me. That is some good news. Otherwise, if it didn't, then I knew that I was doing something wrong. So 11 plus 4 is going to give me a 15x squared. And I'm going to drop down everything else, so negative 31x plus 15. Now the next step, I'm going to look at my 3x, and I'm also going to be looking at this 15x squared. So 3 goes into 15 5 times. And I need one more x to get to an x squared. Okay, so now I'm going to take that and put it over to the side. So I have my 5x, and now that's being multiplied by my 3x minus 2. So when I multiply that out and distribute, I'm going to have a 15x squared minus 10x. And of course, this is where I actually multiply by a negative, so that's the same as switching my signs. So negative 15x squared plus my 10x. So negative 15x squared plus my 10x. So the first term cancels out, which is fantastic. That's exactly what I want. And then I have negative 31 plus 10. So that's going to give me a negative 21x. And I'm going to drop down that positive 15. So now it looks like I'm looking at a 3x and a negative 21x. So 3 times a negative 7 gives me a negative 21. And the x actually matches, so I'm going to be good there. So over to the side, my scratch work, -7, and it's being multiplied by that 3x minus 2. So when I distribute, that's a -21x plus 14. And of course, I am actually multiplying by a negative, so this is really a 21x minus 14. So 21x minus 14. So now I can see that the 21x's cancel. And then 15 minus 14 gives me a +1. So that is my remainder. So I can say that my answer, and I can write it two different ways. The first way I can write it is the quotient is 2x squared plus 5x minus 7, and my remainder is 1. So that's one way of writing it, the quotient and the remainder. The second way you can write it is as if it's a fraction. So I can write it as 2x squared plus 5x minus 7. And since the remainder is a +1 plus 1 over whatever you divided by, you divided by that 3x minus 2. So this is another way that you can write it. So these two answers are the same. They're just written slightly different, okay? All right, so now that we've taken a minute to kind of revisit that long division, for college algebra, Math 45, there's actually a different way of doing this. Now we actually have something called synthetic division. So here we have a polynomial being divided by the x plus 2. So notice how if we were doing the long division, this is what it looks like. And notice how here they put the subtraction out and then they distribute it. That usually confuses people, and that's why I do the scratch work and do it over to the side. So now what they're doing is they're taking these coefficients. Let me rewrite that. So they're taking all of these coefficients and they are using it in synthetic divisions. So now notice how the coefficients are 2, -3, 4, and 5. So I have my 2, -3, +4, and +5. So that is what they're doing here. And since you are dividing by the x plus 2, well, think about it this way. I have my x plus 2 is equal to 0. So x is equal to -2. So that's why I have -2 over here, because x was equal to -2 once you set it equal to 0. So -2 is what you're dividing by, so it's over on the outside, and then the coefficients go on the inside. So what you do is you bring down, oops, I didn't actually want to highlight that. You always bring down the first term. You just drop it. Whatever that first leading coefficient is, you just drop it down. So then what you do is you are multiplying. So 2 times -2 gives you -4. And then you add on the inside. So -3 times -3 plus -4 is -7. So then -7 times -2 is a +14. And you're adding it to 4, which is 18. And then you multiply. 18 times my -2 is a -36. And then you add. So 5 plus -36 is a -31. So you can say that this is going to be a 2x squared minus 7x plus 18, and your remainder is equal to a -31. And it's always going to be 1 degree less. So notice how this first term is exponent is 3. So that means in my answer, the exponent is going to be 1 less, which is going to be 2. All right? So you want to be careful with that. So that was just kind of a quick overview, but let's actually go into it. So I'm like, okay, well, this is what I have. I have this x minus 3 that you're dividing by. So let's think about that. X minus 3 is equal to 0. So x is equal to a positive 3. So 3 is going to be on the outside. And let's look at these coefficients. The coefficients, you have a 5, a negative 3, and a negative 36. So I have a 5, negative 3, and a negative 36. Remember that first term, whatever it is, you just drop it down no matter what. So that's 5. And so then the numbers on the outside, they get multiplied. So 3 times 5 is 15, and I always add on the inside. So 15 plus negative 3 plus 15 is a positive 12. 12 times 3 is 36, and negative 36 plus 36 is 0. So then my answer, let's think about this. This is degree 2, so my answer has to have 1 less than that, so that's going to be degree 1. So I'm going to have a 5x plus 12. And here my remainder is 0, so I don't really need that. So 5x plus 12 ends up becoming my final answer. Okay, well, I hope this is somewhat making sense. So again, I am using synthetic division to divide this polynomial by this x plus 7. So remember, I'm going to take that x plus 7, set it equal to 0, so I have x is equal to negative 7. So negative 7 is going to be on the outside. Now I want to be careful. Look at your degrees here. This is degree 4, degree 3. Where's your degree 2? It's not there, so you're going to have to rewrite this. So I want to make sure that this polynomial is in descending order. And you add 0 as placeholder. So this is really 3x to the 4, okay, plus 18x cubed, okay. So I have degree 4, I have degree 3, but I don't have a degree 2. So this is where my placeholder is going to become 0x squared, okay. And then I have a negative 3x. And remember, x really has a degree of 1. So I have my degree 2, my degree 1, and then of course I have my constant, which is a positive 40. So okay, so now I can see what coefficients I'm going to add here. So I'm going to have a 3, an 18, a 0, a negative 3, and a positive 40. And I'm even going to write that 0 in red. This is really important that you guys see that that 0, if you don't have it, it's really going to mess up your calculation. So it's really important that we have it. Okay, so here we go. Whatever that first term is, you just drop it down. Doesn't matter. It just always gets dropped down. So it's a 3. So remember, the numbers on the outside get multiplied. So 7 times negative 7 times 3 is a negative 21. So negative 21 plus 18 is a negative 3. Negative 3 times negative 7 is a positive 21. Add that to 0, it's 21. 21 times my negative 7 is going to give me a negative 147. And I'm adding negative 3 to it, which is a negative 150. Times that by my negative 7, and that's going to be 1050, and I'm adding 40 to it. So 1090 is going to be my remainder. So I'm going to rewrite this, and remember here, that was a degree 4. So I know over here, I'm going to have a degree 3. It's always 1 less than my original. So my answer is going to be 3x cubed minus 3x squared plus 21x minus 150, remainder 1090. That's a very big remainder, but that happens to be what I have. So, hopefully that's making sense. Now we have something called the remainder theorem. It says if a polynomial f of x is divided by x minus k, then the remainder is the value f of k. Okay, so let's think about this. It says, use the remainder theorem to evaluate this polynomial at x is equal to 2. So, okay, it's telling us specifically that x is equal to 2. So, perfect. I know I'm going to use my synthetic division. So, here we go. I'm going to have my 2 on the outside. And on the inside, I want to check all of my exponents. So I have degree 4, degree 3, degree 2, degree 1, constant. I'm good. So I'm going to rewrite this as a 6, a negative 1, a negative 15, a 2, and a negative 7. So I know for the first term, I'm always just going to drop it down. So this is going to be 6. 6 times 2 is 12. And I have negative 1, so that's positive 11. Positive 11 times 2 is 22. Plus a negative 15 is going to give me a positive 7. 7 times 2 is 14. 14 plus 2 is 16. 16 times 2 is 32. And I'm adding that to a negative 7, so that's 25. So this is my remainder. So, it specifically says, if a polynomial f of x is divided by x minus k, then the remainder is the value f of k. So, f of k is equal to my remainder. Okay. My k value here is equal to 2. That's what it's saying. And I also have that my remainder is equal to 25. So this is specifically saying that f of 2 is equal to 25. That means if I plug 2 into my x value, I will get out 25. For example, 6x to the 4th minus x to the 3 minus 15x squared plus 2x minus 7. So if I were to plug in that 2, then you would see that I would actually get out 25. Okay? And we already knew that because of our remainder theorem. Okay? Well, I hope that's helpful. And that is going to be the end of section 5.4.